A gravitational force F exists between 2 point masses, P and Q, separated by a distance d. What is the resultant force if the mass of one of them, P, is tripled? Well, if we go back to look at Newton's law of universal gravity, if one of the masses is tripled, then the force is simply going to be tripled. If one of the masses is halved, then the force is halved. The masses are returned to their original size, and then both are doubled as well as the distance. So if we double both the forces, it's 2 times 2, which is 4. But if we double the distance between them, 2 squared is also 4. So it's the force times 4 over 4, which is 1. So we're not changing the force. On the other hand, if we had the original masses, what would have to be done to triple the force? So what are we looking at? We are looking at, we had F equals big G M1 M2 over R squared. We now need 3F. Well, one of the ways to look at this is, say that's F1, and then F2 is big G M1 M2 over R2 squared, which we know that we're tripling it. In other words, F2 is 3 times the size of F1. Now, all of this stuff is going to cancel. We didn't change the masses, we didn't change the constant. So we know that F1 over F2 is equal to R2 squared over R1 squared, which is equal to 1/3. So we can say that R2 is equal to R1 squared over 3, R2 squared. So R2 is equal to the square root of R1 over 3.